one in Wiley and another in Scrivener Publishing Company. 7 candidates have successfully completed PhD under her supervisorship in Anna University, Chennai. She has completed transgender projects, modrups, conferences, seminars, FTPs funded by agencies like AICTE, DRDO, TNSEST, etc. She has won many awards and prizes for her academic proficiency during her graduation and profession. She is a recipient of Inspiring Research Supervisor Award for SEEE, an outstanding faculty in electrical engineering from Venus International Foundation. She has completed a world record attempt by participating in 54-hour trainathon as a speaker and certified by Tamilan Book of Records, an Asian world record. She has completed 11 NPTEL courses in Elite, out of which in 2 courses she was the topper. She has acted as chief guest, resource person in many conferences, seminars, FTPs, STTPS, and deliver invited talks. As per Google Scholar, her Hutch index is 15 with a citation count of more than 800. She is a life member of ISTE and IE. Let us warmly welcome Dr. S. Kalyani ma'am to share her expertise and inspire us with her vision on this exciting topic.
So, thank you very much. Hope my voice is audible and my screen is visible.
Yes, ma'am. Yes, ma'am. Audible, ma'am. The screen is also visible.
Sure. Thank you, sir. So, very happy to get virtually connected with all the faculty members of various institutions in and around the various states who have enrolled for this ATAL FTP online course. So before I start off with my session, I have to place a token of gratitude to the management principal of Kamaraj College of Engineering Technology, where I have already served for more than 12 years, and also the HOD and the Dean Research of the EEE department, Dr. D. Prince Winston, who is a close friend also. So thank you, Dr. Prince, for inviting me and accommodating me as one of the keynote speaker in this particular FTP. So I'm very happy to be a part of it. So I have seen the schedules also very neatly. They have scheduled the sessions with various emerging technology topics. So today the era for electrical engineering is in the field of electric vehicles as well as green hydrogen energy. So both of them has been widely covered in the sessions. I think now we are in the 8th session. So I will be touching upon the EV integration in smart grid. So before directly jumping into the topic, so I would just wanted to know from the participants before we start with this particular topic. You have heard a lot of sessions as of now. This is the 4th day for you. For the past 3 days, you have been listening to a number of sessions. And just before my session also, Dr. Kumaravel sir from NIT Calicut would have addressed you on the hydrogen fuel cell technology. So it was very nice. So can you just put it in chat box what you really know about electric vehicles before I start off with this session? So participants, I want the session to be more interactive rather than me talking and just you listening. So let us not be like a normal classroom environment. So let us make the session interactive even though we are virtually connected. So can you just put it in the chat box? What comes to your mind when you think of EV, electric vehicles? I want the responses. You can just put it in the chat box, right? So any responses? Participants, please feel free to interact. Otherwise, you can unmute and tell us. Or else you can put it in the chat box. So I think all our faculty members, you may know very well about EVs. Okay. Okay, fine. Okay, so let me start with the session. So this is the outline of the presentation which I planned for this another 1 hour 30 minutes, the time which has been allotted for me. At the end of the session, I will conduct a game also for you so that you will have a refreshing one before you leave the day. Okay. So initially, I will start with the introduction to electric vehicles. So I don't know how far the things have been covered. So let me give a brief overview of the electric vehicles and how the transition is happening from ICE to EV transition. What are the key components of electric vehicle? What are the types of electric vehicles which is popularly manufactured by EV industries, automobile industries in the market? And then I will touch upon smart grid. I think in none of the sessions, smart grid has not been spoken about. So I will give an introduction to smart grid. Although smart grid is also a big ocean. If you see, EV is a big ocean. Okay, it's a big. Nowadays, many universities they are starting courses related to EV exclusively. Even SRM University they have a separate course for 4-year course on EV. So such a wide, vast topic. We have many things to learn. And also the smart grid is also a big topic, right? And finally, we are going to talk about EV integration in smart grid, which is going to be still more bigger. But I have made it as brief as possible. So because we are all teachers, right? If we are able to get some bird's eye view, we can go and explore. There are a lot of research articles available. So we can go and explore. If we are really interested to do some research, we can take up a problem and we can start addressing on it. Okay. So if you think of EV, now it is coming up in a big pace even in our country, India. Okay, although it was coming in a big market in China and US, now India is also promoting a lot of electric vehicles to be running on the road, especially in metropolitan cities and urban places. Okay, so this is the outline of today's presentation. So let me start with the introduction to EVs, right? So whenever you think of EV, so what comes to your mind is basically we know what is a vehicle is. Vehicle is used for movement, commutation, moving from one place to another place. It may be a cycle, it may be a two-wheeler, it may be a car or a bus or a truck or whatever it is, right? So when you think of electric vehicle, it is going to be powered by electricity. So that is a very simple thing how you can define electric vehicle is. So electric vehicle, how can you before we define electric vehicle, why we have to go for electric vehicle? What is the scenario which pushes us to go to electric vehicle? Because of the greenhouse gas emissions. Okay, the excess CO2 emissions which is coming up. Okay, we all are aware of it. So we know that the target should be net zero carbon emission target. We are all moving towards it. So if you see this statistics globally as well as in the Indian context, so if you just look at the bar chart or the pie chart, whatever has been presented in the slide, you will be able to understand that although India is standing in the 4th place, but this is not acceptable. Okay, around 2.7 billion tons of CO2 is being emitted every year, and this is going to pollute the atmosphere a lot. And hence, this will lead to a lot of diseases and health hazards, and lot other problems are going to emerge in the near future if we are not going to reduce the CO2 emissions, because the number of vehicles are increasing day by day because of the increased population, and number of vehicles per person is also increasing. So in a home, every person is now having a vehicle, either a two-wheeler or a car. So it is maybe 2 vehicles per person. That is the ratio which is going up in the big cities. Okay, and here if you see in the CO2 emission, India is topping in the 1st position. Okay, so we have to take some measures in order to reduce the CO2 emissions and the tons. Okay, so this is the per capita emission of these top 7 emitters in the statistics which is taken in the year 2021. Okay, of course now it has been little bit reduced because after 2020, after the COVID situations, only electric vehicles started promoting in a wide pace. Okay, so this is the greenhouse gas inventory statistics, and here you can see that for the greenhouse gas emissions is more from the energy sector. Okay, so we have to concentrate on this energy sector, which contributes to 75 to 80%. So all this has motivated us to promote EV in the market in the various countries. Okay, so again the same statistics I'm going to show you. Okay, the per capita emissions of CO2 per year. So here this is this also includes UK. Okay, when you tell European countries, it also includes UK. So here we are more interested in our country, that is India. So here you can see around 1 megaton. You know how much tons it is? It is around 1.9 tons. Okay, total megatons, if you see, 2,597 megatons of CO2 is emitted per year. So this statistics is as per the emissions database for global atmospheric research. Okay, so all this has motivated us to move towards EV. So that is the main reason, is to reduce the CO2 emissions and the greenhouse gas emissions. And moreover, fossil fuels are going to deplete in the near future, and hence we have to find some alternative sources for powering the vehicles. Okay. So what is basically an electric vehicle? So which we are all aware of, right? So it is going to be powered by electricity. So if it is going to be powered by electricity, we need an electric motor, and the electric motor in turn needs to be powered by a battery. Okay, so the battery is the major heart of the electric vehicle. The battery is the major heart of electric vehicle, and this battery is going to power, or it is going to provide the necessary supply to your electric motor. And it is basically, you can think of a BLDC motor or a PMSM motor. So here the battery is going to give the DC as the output, and we are going to convert into AC and feed to the motor, and again the motor is going to convert into mechanical energy, and it is going to propel the wheels of the vehicle. So this is the basic idea behind the concept of EV, or what is EV, whatever we want to define about. Okay, and we need to charge the batteries. So we can charge the batteries either internally or from an external source. So that we will come in the forthcoming slides. Okay, and the reason or the benefits why we go for EV technology is to reduce the greenhouse gas emissions. I think participants, kindly mute your mic. Okay. And in order to reduce the global warming effect and increase the public health also. So we are very much interested to improve the public health so that they are not affected by much diseases, especially because of the polluted environment. So EV will help us to improve the public health, reduce the air pollution, and reduce the dependence. So we need not have to depend on the petrol or diesel fuel for our vehicles. So we can reduce the dependence, and EV is going to give a lot of job market for diploma holders, for ITI peoples, and also for the engineering people, engineering graduates. So there is a lot of job market in EV technology, maybe in the battery, BMS system, controller design, motor specifications, motor design, and the EV assembly as a whole. So electrical engineers, mechanical engineers, even computer science engineers, they have a vital role to play in EV industries, right? In various automobile industries, which manufacture different types of EVs. So the benefits goes, a lot of benefits are there, environmental friendly, and very important is the initial cost may be high when you go for purchase of EV, but the operating cost and the maintenance cost is going to be as low as possible. Okay, I will come to you with the statistical data to tell you how the operating cost and maintenance cost is going to be less. Okay, and if you take two-wheelers, we can conveniently charge from the home itself. So in the home itself, we can use the charging port, whereas for cars, we can go for some charging stations to charge. Okay, so we can even conveniently charge from the home, and the EV is going to have a better efficiency because of the concept of regenerative braking, which I will discuss about regenerative braking also in the forthcoming slides. And when you are, it's very easy to drive. It gives a lot of comfort. So the torque, if you see, immediately based upon the speed requirement which the user requires, either the user may accelerate the pedal or decelerate the pedal. Okay, accordingly the torque will be, because the motor will provide an instantaneous torque. So compared to the IC engines, your motor is going to support with the instantaneous torque in a way that you will not have a jerk. You will not experience some. You will have a very luxury comfort while traveling in the electric vehicles. A very smooth instant torque is being produced, and noiseless operation, of course, that we know. And then health benefits are there, and a lot of innovations are happening. So as engineers, as researchers, you can do a lot of research in the field of EVs in various components, especially in the battery technology. and lower fuel cost, as I already mentioned, because petrol diesel is not required, and government is also giving lot of incentives. Okay, so basically this is the basic how you can understand how a EV works. Okay, so the major component here you can see electric motor. Okay, that is the one which is going to drive your wheels, and then your inverter is there. So you know that we need to convert the DC to AC, so you need an inverter. Of course, apart from that, you have some auxiliary battery system also. So there are two batteries. One is a main battery, which is going to power your electric motor, and you have an auxiliary battery. So for that auxiliary battery, you have to step up your voltage. Okay, step down your voltage. For example, if your battery is specified at a voltage of 48 volt, you need to step down to 12 volt. So for that, you need a DC-DC converter. So all these converter systems will be positioned, and then you need to have a transmission system. As in IC engine vehicles, we have the transmission system. We need to have a powertrain and a transmission system in order to power the wheels. So we need to transfer the energy from the motor to the wheels. So for that, we need the transmission system. Then EV battery is there. Then you have the battery charger. So these are the major components of the EV. And if you look back to the history of the development of EVs, okay, so EV is not invented recently. It has started in the year 18th century itself. In 18th century itself, a scientist Hungary, so he invented that a car can be driven by an electric motor. That was the first foundation laid for the invention of EV. Then later on, they invented the EVs, which is being powered by non-rechargeable batteries. Okay, so because of that only EVs did not become popular, because when we go for non-rechargeable batteries, we have to throw the batteries as we use in our wall clocks, in our remotes, or any other devices, home devices which we are using. Okay, so it's not possible, right? Because the batteries are costly. So in the 1980s, lithium-ion batteries were developed, so which was actually having the facility for recharging. There was an option for recharging. That is where the EVs, that is in the 1980s, beyond the 1980s, if you see US, they have done a lot of research to promote the EVs. Okay, this is the history behind the development of EV. And here, if you see, in 2014, 23 EV models were developed, and they were rolling out on the market. Nearly 2 million EVs on the US roads in the year 2020. So in US, if you see, most of the cars which is running on the roads are electric vehicles. Okay, so this is a history behind the development of EVs. And here you can see that the same thing, I'm just put it in a form of a milestone, starting from 18th century to 2010. So initially EVs were developed, then EVs disappeared because of the presence of non-rechargeable batteries. Then again EV started blooming up because of the high oil price and increased air pollution. Okay. Now the transition. So we have seen what is basically an EV and the history behind the development of EV. How the transition really happened from IC engine vehicles to EVs. So in order to illustrate this, let me take you a small example. I'm going to take a Tata company's car. So one is a Tata Nexon model, which is a petrol vehicle, and another one is a Tata Nexon EV model. Okay, so the initial price is given here for the Tata Nexon model, which is nearly 15.5 lakhs. And the daily, assuming that the car is going to be used for a traveling a distance of 150 kilometers per day. Okay, and this particular Tata Nexon petrol model is going to give a mileage of 17 kilometers per liter. So considering this petrol cost, approximately the fuel cost for traveling 150 kilometers per day. So every day the user has to spend 882.35 rupees of petrol charges in order to travel a distance of 150 kilometers. So the per day cost is 882.35 rupees. Now, what will be the per year cost? Assume that the vehicle is being used in a year. We know 365 days are there, but we are not going to use the vehicle all the 365 days. Every day we will not be using the vehicle. So on an average, if I assume that 240 days, okay. So I'll just take the calculator. If you have calculator also, you can just check it out. Okay, so I'm going to take a calculator to show you. So 240 days I'm taking in a year. 240 days the vehicle is being used to travel a distance of 150 kilometers per day. So 240 into 882. So per day cost is 882.35. So per year cost will be 240 into 882. That is approximately 2,11,764 rupees. Okay. And the maintenance cost is taken as 30,000 on an average for a petrol vehicle per year. Maintenance cost, service cost, all the oil cost, everything is taken as 30,000. Now, what will be the total cost to the owner? TCO is called total cost to the owner. So that will be the total price of the vehicle per year cost plus the maintenance cost. So the total cost of the vehicle is 15.5 lakhs. Okay. So you can also parallelly do and check it. Plus per year cost is 211,764 plus 30,000 maintenance cost. So it is approximately 17 lakhs. So this is the total cost to the owner as soon as he at the end of the first year. Okay. Now, if the same vehicle is used for another 5 years, what will be the total cost spent by the owner? So here you have to take this value 17 lakhs, 17.91 lakhs value plus 4 times the per year cost plus 4 times the maintenance cost. So you have to take this value plus 4 into that 2.11 lakhs plus 4 into 30,000. So if you do that calculation, you will be getting 27.58 lakhs. The same thing if you calculate after 10 years, that is 9 times. You can take this value plus 9 times this value plus 9 times this value, around 39 lakhs. So this is the total cost at the end of 10 years, which you will be spending for a petrol vehicle of a Tata company. Okay. The same analysis I'm going to take for a EV model. The initial price is high. This is 15.5. This is 20 lakhs. The 5 lakhs, it is higher. The daily travel distance is also the same, 150 kilometer. And this is a pure battery vehicle. So it is having a higher range of 450 kilometer. For one full charge, it can travel a distance of 450 kilometer, assuming that. Okay. And the per kilometer charging cost approximately is taken as 0.57 paise. Okay. So considering this 0.57, so total distance is 150. So 150 into 0.57 will give me 85.5. That is what is the per day cost. So per year cost, multiply this by 240, you'll be getting around 20,520. Maintenance cost is very less. We'll take only J for example 5,000. So if you add this, okay, these figures, I'll go to the slideshow. So if you add this figure 20 lakh plus 20,520 plus 5,000, it is around 20 lakhs 25,520 rupees. Okay. So the same thing at the end of 5 years, similar procedure, multiply this by 4, multiply this by 4, add it with this particular figure. Similarly, at the end of the 10th year also, you can do the same calculation. So you just comparatively, you compare an IC engine vehicle with a pure battery EV for the same model. Okay. So here we are spending around 40 lakhs. Here we are spending only around 22.55 lakhs. So as electrical engineers, we should be able to convince the consumers who are coming for the purchase of EVs. So we should tell them that initially all the people, they are having the mindset that EV is costly, we cannot afford for it. But we have to see the long-term benefit. What is the long-term benefit and how much money we are going to get and what will be the payback analysis. Okay. So this will help us to appreciate that yes, EV is affordable and we can purchase it, and it is definitely going to be a profitable one for us. Okay. And this cost, this 20 lakhs, which is given as the initial price of the vehicle, most of the cost, 50% of the cost is only because of the battery. So a lot of innovations are now happening on the materials which are used for the anode, cathode and all. So in a way that we have to go for a higher energy density. So that will we are working. The researchers are working in the field of choosing materials with higher energy density, better safety, high that is long cycle life of the battery. So and better thermal stability. So a lot of research is going on as well as reducing the cost of the battery. In a way, near future, in another 2-3 years, this initial price also will be reduced. So if you take a Hyundai company, previously I shown a Tata one. Hyundai Kona IC vehicle, and then this is a hybrid electric vehicle, and then electric vehicle. Okay, so here this is the price which is given in terms of dollars. So of course the battery electric vehicle is a bit costly, $34,000 to $42,500 compared to the hybrid electric vehicles. So this gives the mileage. Okay, so 12.7, 21.2. So here you can see the mileage. So although for battery electric vehicle we cannot give mileage per liter, just for a comparative analysis I have given. So this is going to give approximately 50 kilometer per liter. Okay, and the CO2 emissions here you can see how much it is reduced, especially in battery electric vehicle. It is going to be a tailpipe emissions is going to be almost nil, and the battery size is also given. So nowadays people, instead of going for pure battery vehicles, they move for the hybrid electric vehicles because it is very much affordable and it has a lot of benefits as well. Okay. So what are the challenges which we are facing in EVs? Okay. So what are the major challenges? First is high initial cost. Okay. Second, very important challenge is charging infrastructure. Lot of research, even in our office, we are a separate course we are doing on EV charging infrastructure. We have a separate stack for EV where we have a course like foundations of EV, we have a course like battery technology, we have a course for charging infrastructure, we have a course for embedded systems for EV, and then design and simulation of EV. So all that put together, we have 6 courses for EV stack separately for electrical engineering students, mechanical engineering, as well as CSE and IT students. Okay, so we are extensively working on this particular aspect of charging infrastructure, and this is going to be a major challenge, especially if you see when more number of EVs are promoted in the when more number of EVs are coming up in the market, how to charge the EVs, that is going to be a big challenge. Only the grid has to support. If the grid has to support, the grid should have more stability. Okay, because the load on the grid is going to increase. Okay, so how the grid is going to support? Because the grid needs a sufficient power to charge the electric vehicle. So what is the how we are going to handle it? And moreover, the battery which we are using in EV is a DC one, whereas the grid is going to supply an AC power. So all that challenges, converter topologies, how we are going to handle the switching loss in the converters, harmonics, and other problems, everything is going to be a major challenge. And range anxiety. So many people, why they don't go for EVs, they have a fear that the vehicle will stop in the middle without any charge. So that is the problem. Okay, the range anxiety is there. How long my vehicle will move for this particular charge, that is there. And battery technology constraints, charging speed, it takes more time for charging, and then grid capacity, as I told, and EV design constraints, EV development and validation challenges are there, and supply chain challenges. So these are the various challenges which we face with respect to EV. And this, if you quickly look at the statistics, okay, I'm not going to tell each and everything. So if you see here, there are around 1 lakh charging stations in US. Okay, whereas in China there are around 6 lakhs charging stations alone. Okay, and in California alone, the number of electric vehicles is anticipated to increase to, as of now, if you see, around 2 million vehicles are running in a city called California alone in US. It's not the entire US, only in California. Okay, which is expected to increase to nearly 4 million by 2030. As of now, it is around 2 million. So which is expected to increase around 4 million. And if you see the CO2 emissions, it is as low, because considering the hybrid electric vehicles, in hybrid electric vehicles, there will be CO2 emissions. If we are using pure battery vehicles, there is no CO2 emissions. So the CO2 emissions is also drastically decreased. Around 0.6 tons of CO2 is emitted by electric vehicles after running around 1 lakh miles. Okay, you just imagine after running around 1 lakh miles, especially for hybrid electric vehicles. So the key components of electric vehicle, if you take a two-wheeler, this is how you can imagine the components. Motor is there, which is in-house, which is called the in-runner motor and out-runner motor. There are two things. So if we discuss about the motor separately, we can discuss more in detail about those things. And then we have the controller, and then the junction box is there, the converter is there, you know the role of converter, then battery system, and then MCB. Okay, so these are the main components for a two-wheeler electric vehicle. And if you take an electric car, whether it may be a hybrid electric car or your, this is a very famous picture available in Google. Whenever you type electric vehicle, you can see this picture. Okay, so I thought let me take the same picture which you are all familiar with. Okay, so this is the auxiliary battery I told, which is used to power the headlights, wiper, or other accessories which is available in the automatic door system. For all that, we need battery. Okay, so that is being powered by the auxiliary batteries. Then we have the cooling system, DC-DC converter, power electronics controller is also there, and you have the IC engine because this is going to be an hybrid electric vehicle. So you have the IC engine. Then because of IC engine, you need to have an exhaust system to take out the tailpipe emissions, that is your CO2 emissions. Then the transmission system. So this electric, so you will have a motor generator set 1 and set 2. Okay, so this electric generator is mainly used for the regenerative braking, so which I will come in the forthcoming slides. And then this is your fuel tank and the traction battery pack. This is the main battery pack, okay, which is going to power your motors. So these are the various components which I have already discussed. Let me skip the slide. Okay. And let me have a quick video in order to show you how the Toyota model looks. Okay. HEV. This is a hybrid vehicle Toyota model. So are you able to get the audio?
Yes, ma'am.
Okay, thank you for your response. So here I'm just going to illustrate this video to show the various modes in which EV works. First, we start with startup mode. That is when you start the vehicle. When you ignite and start the vehicle. So this is a hybrid electric vehicle. So we should know when the motor is operating and when the IC engine operating and when both are operating. Okay. So the main component, engine, motor, battery. So when you start the vehicle, we need the initial torque should be high. So the motor is used when the vehicle starts. Okay. So you closely observe the video. So here when starting engine is stopped, motor is on. Next we have cruising mode. Okay. Cruising means maintaining a constant speed. Here both engine and motor together work. So full acceleration, it goes to the motor mode. Then decelerating is you're reducing the speed, so that is the process of regenerative braking. So engine is stopped, resulting in high efficient energy recovery in deceleration mode. So these are the different models. Toyota Prius, Prius C Insight. So you can see the IC engine vehicle, conventional cycle and Atkinson cycle. This is what is used in the HEVs, hybrid electric vehicle. this is the power control unit. So you just got an idea of how a Toyota HV model looks like. Okay. Now I just wanted to tell you about the regenerative braking. Okay. So in regenerative braking, if you see the basic concept is when you decelerate the vehicle. Okay. When you stop the vehicle, not only during deceleration, when you stop the vehicle, when you bring the vehicle to a halt condition, what we are doing, we are releasing the energy, we are expending the energy. In a normal IC engine vehicle, the energy will be completely wasted. Here, the energy will be simply wasted as a heat, but here it is going to be reused. Okay, that energy is going to be again given back. So the motor is now acting as a generator, and that energy will be fed to the battery. So as a result, the kinetic energy is being converted into the electrical energy. So that is the concept of regenerative braking, which you are aware of. Now you just have a look at this video, which will help you to understand the concept of regenerative braking very well, which is a very important advantage of EV. So the efficiency of electric vehicles is improved or enhanced because of this mechanism being inbuilt in it. Okay, so just listen to this video.
Regenerative braking is the recovery of kinetic energy during braking. In vehicles with a combustion engine, a majority of the kinetic energy is converted during friction braking into heat and emitted unused into the environment. Hybrid or electric vehicles can use the electric motor to recuperate at least a portion of the kinetic energy for reuse. When the driver steps on the brake, the electric motor switches to generator mode. The drivetrain transfers the kinetic energy to the generator, which converts it into electrical energy. This energy is stored in the high-voltage battery. The generative braking torque of the electric motor, which is the result of energy generation, decelerates the vehicle. At low speeds, for example, shortly before the vehicle comes to a stop, the electric motor can no longer supply sufficient generative braking torque, and the friction brake must be activated. To maintain the required deceleration, the braking torque from the friction brake is continuously adapted to the current generative braking torque, a process called torque blending. Regenerative braking systems from Bosch play a crucial role in this process. For example, the electromechanical brake booster iBooster in combination with ESP-HEV for hybrid and electric vehicles, or alternatively, the integrated solution integrated power brake, detect the driver's braking request and regulate the torque blending. With all these braking system variants, a deceleration rate of up to 0.3 G is possible. In the case of full braking or in unstable driving conditions, the vehicle is usually decelerated solely via the friction brake, as wheel-specific interventions are required. Overall, regenerative braking makes far less use of friction braking. This leads to less wear and a significant reduction in brake dust. Regenerative braking systems from Bosch for increased ranges, lower fuel consumption, and an improved CO2 balance.
So this is a video taken from the Bosch. Okay, so hope you have understood the concept of regenerative braking through a small video, how the kinetic energy is converted back into the electrical energy, and thereby it is used to power your PPS, that is a peaking power supply, which is nothing but your battery. Okay, so this is another picture which shows the plug-in hybrid electric vehicle, which is called a Range Rover. Okay, so let me skip this, and because we are lacking of time. So this is actually this Range Rover. It works in 3 modes. One is hybrid mode, okay, which automatically combines power from motor and petrol engine. So both modes, both IC engine, a percentage a contribution from IC engine and a percentage from electric motor. That depends upon the speed in which the vehicle moves. Or EV mode alone, that is on electric motor, or save mode. In save mode, it will prioritize the combustion engine as the main power source and battery as the backup power source. Okay, depending upon the amount of charge available in the battery. So if you go for the types of electric vehicles, I think this you are very well aware of it. Battery vehicle, plug-in hybrid electric vehicle, hybrid electric vehicle, and fuel cell. Okay, so in the market, if you see more HEVs are now coming up in the market, or plug-in hybrid electric vehicle. These two are very popular. The next priority is given for the battery electric vehicle. However, for fuel cell electric vehicles is not that much promoted. Still, it is under research. Okay, the lot of developments are now happening. Okay. So if you see these, the basic idea of battery electric vehicle is it will be having only the electric motor and the battery. It's solely the only power source available is your battery come electric motor. There is no other alternative power source. So the tailpipe emissions is 0 and the range is higher. Range need to be higher. For one full charge, it should go at least to the range of 200 to 400 kilometers. And if you see Tesla Model 3, Nissan, Audi e-tron, they are all the models belonging to the battery electric vehicles. And if you go for plug-in hybrid electric vehicles, so here you have both IC engine as well as electric motor. At the same time, the battery is being connected to an external charging port, external electrical outlet. So only it is called plug-in hybrid electric vehicle. Hybrid because it has both IC engine as well as the electric motor. So you can see the arrangement over here. You can understand. Okay, so here IC engine is given the first priority and battery is used as the standby system. Okay, during certain modes, battery takes up the picture, like during starting mode, during some high acceleration. Okay, so here the range will be less. And if you see, these are the various models: Mitsubishi Outlander PHV, BMW X5 model, Volvo XC60 Recharge. All these models belonging to the plug-in hybrid electric vehicles. And in hybrid electric vehicles, it is very much similar to this. The only thing is you don't have the plug-in arrangement. So here, the only way through which the battery can be charged only through the regenerative braking mechanism. That is the only way the battery can be charged. Okay. And these are the various models like Toyota Prius, Honda model, Ford Escape hybrid model. And fuel cell means you'll be are going to have the hydrogen tank. So you are going to supply the necessary power to the electric motor through the fuel cell. Okay, so there in hybrid electric vehicle, or IC engine itself will provide the necessary power to the battery system because you don't have any external charging port. But here fuel cell is being used as the major source along with the battery and the electric motor. But this is very, very costly because hydrogen gas is very costly. You need to have an hydrogen tank. You need to fill the hydrogen tank with the hydrogen gas. Okay, so you need to have a hydrogen fueling station. So all this is going to be a big thing. So big revolution. So even in European countries and Western countries, still this has not been promoted in a wide base. Okay, so Toyota Mirai, Hyundai model, Honda Clarity fuel cell. These are all some of the models which is manufactured with respect to the fuel cell EVs. So this gives a comparison which I think you can understand. Let me skip this slide. So this is what is the main thing, the key components of different types. So if you take the normal IC engine vehicles, whether it's a petrol vehicle or a diesel vehicle, the only source of energy is your fossil fuel. And the powertrain device, the device which is going to drive your wheel is your engine. And emission, of course, there is going to be emissions. Okay, but hybrid electric vehicle, you have both fossil fuel battery, engine, motor, both is going to act as a powertrain device. Of course, you have emissions, but the percentage of emissions is reduced compared to the IC engine based vehicles. So the same thing holds good for plug-in electric vehicle also. For battery and fuel cell vehicle, this is the source of energy and this is your powertrain device, and they are not going to be any emissions because of the absence of the IC engine. So having understood what is electric vehicle, what is the history behind the revolution, and having understood the key components of electric vehicle, how the transition has happened from IC engine to electric vehicle, what is the motivation to promote this electric vehicle and types and all. Now let us jump into the topic of smart grid. Okay, again, the smart grid is going to be a big ocean. Okay, so we know the conventional electric grid. We have in our country, India, we have 5 regional grids and 1 central grid. So you are all aware of it. We have a southern grid, western grid, eastern grid, northern grid, and a northeastern grid. Okay, and which is also highly interconnected. So during the 2013, We have interconnected all the grids, and we have attained the mission of one nation, one grid, one frequency. Okay. So this grid need to be converted into a smart grid. So whenever you want to convert anything into a smart, you need to have all the technologies built into it, especially the information and the communication technologies. That is the digitalization. So you are going to convert the conventional grid into a smart grid by adding lot of digitalization, by bringing the technologies of IoT, artificial intelligence, automations in different sectors. So you need to monitor and manage the entire transport of electricity, starting from the generation to the end consumer, and how we are going to meet the demand. So demand is the only component, or the load is the only component. I would say always in power systems, load is the culprit, because we don't know how the load is going to vary. Okay, depends upon the seasons, depends upon the festival seasons, the climatic situations, and all these things is going to affect your load parameter. How we are going to vary, or how we are going to meet that drastic electricity demand of the end users. So that is where the smart grid plays a vital role. So this is a big ocean. So the entire network should be incorporated with all these technologies to convert the grid as a smart grid. So the key features, if you see, the system should be more and more reliable. So how it can be made reliable? You can add the renewable energy sources. You can pool it. So the concept of distributed generation, microgrid, all that. You can go for, instead of having a centralized generation, you can go for a decentralized generation. So you can produce power at the point of the load consumption itself. So for example, in my house, I can have a solar plant, rooftop solar plant installed, which will feed the load of my house. Okay. So this is how the concept of reliability and how it is flexible. So the very important feature of smart grid is self-healing. If some fault occurs, how it is going to see, self-healing means what? Suppose if I am, as a human being, I get affected by some disease. If my body is having a sufficient immune power, I can fight with the disease and I can come out of it. That is what is called as self-healing. How the grid is made stable in such a way that it is going to identify the fault by itself, and it is going to clear by itself. So that is a major feature of the smart grid, self-healing. You'd have heard of it. And efficiency, sustainability, how we are going to make the environment as a green environment. Okay, so we have to promote sustainability. We have to have a sustainable energy environment, or a sustainable grid. How that is going to happen? How we are going to, how the customers are going to play a vital role in electricity market by the incorporating the smart meters. So all that is going to create a big revolution in smart grid. So a lot of smart grid pilot projects have been launched in India, but still, if you see the smart grid, so EVs are promoted to a much wider base nowadays. But smart grid, if you see, we are just talking in terms of text. We are just talking in terms of research. But how much it is implemented in practice, even incorporation of smart meters is still under research in India. Whereas in Western countries, they have almost replaced all the digital meters into the smart meters. So if you think of the smart grid, this is the pictorial view. You can understand. So any power system, if you take, you're all electrical engineers, you know about it, or maybe even a non-electrical engineers may know about it. Power generation. So you have generation, transmission, and distribution. These are the three major sectors. Okay. So in generation, initially we relied only on thermal. Now we are going to have solar, wind power plant, and other fuel cell, and other geothermal, tidal, and other sources of energy as well. And we need to have a complete control center to monitor the transmission and distribution of the electric power. And coming to this is the main part. This is the main part which promotes the grid as a smart grid. The storage, the power storage, and the consumer. So here you have electric vehicle, you have smart home. How we are going to control the various appliances which you are going to use in the home in a very efficient manner, so that you are going to save energy. In a way, you are going, the consumer is going to be a procurer. Okay, so that means you are going to generate power as well as you are going to distribute power. Okay, so both you are going to do. You are going to act as a utility as well as you are going to act as a consumer. So that much we have to play. The customers have to play a vital role. Okay. So this is how the transformation of grid happened. If you see, This is taken from this particular journal. Okay, so if you see the transformation of grid, okay, in transmission and distribution, we have to incorporate more and more of automation features. For example, reactive power control. So each and every topic is a major research. How we are going to handle it. Okay, so of course the transmission is still AC transmission. Although there are few HVDC transmissions here and there, 90% of the transmission happens only through overhead transmission, AC transmission. Okay, so what are the automations we can bring into it? How we can monitor the load? Okay, so all the how we are, can balance the load and generation. So here, if you see, the wind is being brought, the PV is being brought into the generation sector. Okay, and energy management. Here we have plug-in hybrid electric vehicles, smart lighting system, efficient appliances. So this is how the transformation has happened from the basic conventional grid to the smart grid, and how we are going to handle the varying load demand. Okay. So the conceptual model of smart grid, this is also a very famous diagram. Okay. So whenever you take the smart grid, there are 7 domains. You should be.
Ma'am, kindly unmute yourself. Excuse me, ma'am. Kindly unmute yourself.
Ma'am, your voice is not audible, ma'am. Ma'am, your mic is muted. Ma'am, kindly unmute and then speak, ma'am. Ma'am, kindly unmute and then proceed, ma'am. Ma'am, kindly unmute and then speak, ma'am. Ma'am, your voice is not audible, ma'am. Ma'am, your voice is not audible. Kindly unmute, ma'am.
Ma'am, your voice is not audible. Please unmute it.
Hello,
Ma'am,
we are
your
getting
voice is not
video
audible,
only. Hello, we are getting video only.
I'm extremely sorry.
Now audible, ma'am. Audible.
Okay. Because
Now it's
I'm
okay,
only
ma'am.
able to see the PPT. And echo is coming.
Okay, ma'am.
Is it fine now?
Ah, yes,
Okay,
ma'am.
madam. Okay, madam.
Right.
So sorry, actually I was discussing about smart grid. Why I'm getting an echo? I don't know. Okay, so the 1 minute, sir. I'm getting an echo. Now is it okay? Still, why I'm getting echo? I don't know. 1 minute. My voice. Yes, I'm getting my voice. I will leave the meeting and come. Hold on for a minute.
Okay, ma'am. Okay, ma'am.
1 minute.
Okay, madam. Okay, madam.
Now is it okay?
It's all right, ma'am.
Okay.
Okay, ma'am.
So actually we were discussing about smart grid. Okay. So if you see, this was the topic we were discussing. I hope the screen is visible and my voice is audible.
Yes, ma'am. Yes, ma'am.
Okay. So these are the
Yeah, ma'am.
various key components of smart grid, which I just showed you a minute before. So what is the critical developments happening in the smart grid? If you see, first is the grid infrastructure in terms of generation need to be expanded. How we can expand? Because in order to meet the demand, we should have sufficient generation. So we have to accommodate for renewable energy sources and the microgrid system. That is a distributed generation microgrid. There are a lot of research going on. So what is the research? See, we have different types of DGs which supply only active power, DGs which supply reactive power. Sometimes we need to manage the reactive power also. That is a very, very important thing. in order to maintain the voltages at a constant level or between the acceptable limits. So a lot of research is going on regarding optimal location in a particular network where we have to locate the DG, what will be the sizing of the DG, how to do the loss minimization, how to do the cost minimization. So a lot of opportunities are there. My own research student has done related to this optimization of the DG units. Okay. So that is the first development which is happening. Second development is penetration of information technology to digitize the entire grid. Okay, so how far you are going to penetrate the information technology in terms of putting the data in the cloud, or how we are going to manage, for example, home automation through IoT, how we are going to control the various home appliances, how we are going to convert into a digital technology. So that is the second development. Third development is new applications, for example, smart meters, wide area measurement system, PESA measurement unit. So what are the new applications that can be added to make the grid as a smarter grid? This is how the development is being happening. And the National Smart Grid Mission, okay, if you see, it is established by the Government of India in the year 2015 in order to accelerate the smart grid deployment in India. So a lot of smart grid pilot projects have been taken. So if you go to the website of National Smart Grid Mission, you will get the full details. So you can take this as, suppose if you are teaching the course Smart Grid for PG students or UG students, you can give that as an assignment. The students can come up with what are the pilot projects happening in India or in the global environment. So they can just understand the projects and what is the level of the project execution, all that they can read it, so that will give a better understanding for them in what pace we are moving. Okay. So the technology drivers, if you see, who are the major technology, which is the technology which is driving or promoting the concept of smart grid. First thing is the advanced technologies in the operation and maintenance of the transmission and distribution network with respect to embedded system, with respect to automation and control and protection also. We are now moving to the numerical protection. We are no longer using the electromagnetic relays. Now we are using only the numerical protection devices. Okay, even all the switchgear companies like Siemens or any ABB, they are manufacturing only the numerical relays. And what are the data acquisition devices? Then how we are going to incorporate the concept of substation automation, not only in the level of substation, but also in the feeder, that is in the distribution network, that is your ring main system or in your radial system. Then how the customers are going to play a vital role of being acting as both as a buyer as a seller. Okay, and decentralized generation, that is where your renewable energy plays a vital role. And how we are going to monitor the grid state to state, from time to time you are going to monitor the various grid parameters, maybe frequency, voltage, for some fault is occurring or not. So you need to monitor the data with different types of sensors, and you need to store the data also. So real-time monitoring, and you are going to do it. And so here the big data analytics plays a vital role. So these are the various technologies which promotes the smart grid. So the three major technologies in a nutshell, if you put information and communication technology, sensing, measurement, control, and automation technology, then power electronics and energy storage technologies. So in transmission system, we talk about the energy management system, HVDC, FACTS. Okay, and then as I already mentioned, substation. So we have developed an exclusive course on smart grid in our premises, office premises. So I'm actually the course instructor for smart grid. We have developed a 14-week module where we have discussed everything in detail: substation automation in detail, feeder automation, distribution management system. See, everything is a big topic. So if I want to talk about everything, that itself will take more than 3 or 4 hours. Okay, so then wide area monitoring, protection and control. So if you are a power system engineers, you would have heard of all these terms. Okay, automatic fault detection. So a lot of research is going on in this aspect also, using the AI algorithms, machine learning algorithms, how we can do the fault detection and isolation and restoration and outage management system. So now, having understood EV and smart grid separately, let us take a moment to understand how EV can be integrated in the smart grid. Okay, so we all know that smart grid are very advanced grids that is going to use digital technology to monitor and manage the electricity in real time. Okay, and if you want to integrate the EV in smart grid, EV can also act as one of the source. EV can also power your grid. Okay, so it is an emerging and important trend which is aimed at optimizing the usage of energy. Very important is enhancing your grid stability, and EV is also going to promote the adoption of renewable energy sources. So in a way, we are going for smart charging infrastructure where we need not have to rely on the grid. We can have a solar energy system, decentralized system, which will be providing the necessary power for your smart charging infrastructure. In a way, solar is going to give DC, so it is easy to charge your batteries also. Okay, so that level of innovations is being happening, and this is going to provide a great potential when you are going to integrate EV. Already we have integrated renewable energy into the smart grid, so that is going to reduce your CO2 emissions, your global warming effect, your greenhouse gas emissions. So if you are going to integrate EV also into smart grid, that is further going to reduce the emissions, improve your energy efficiency, and it is going to enable a cleaner and a more flexible energy system. Okay, so the full benefits of this integration of EV into smart grid, we can enjoy the full benefits only if we are going to deploy advanced infrastructure in terms of decentralization of your power generation. What are the regulatory frameworks you are going to adopt? So simply you cannot integrate an EV into the smart grid just like that. You have to have the regulatory frameworks and policies and protocols, which the communication protocols or the information technology protocols need to be followed, and the technological standards which need to be adopted as per IEC standards. So let us take a moment to understand the concept of EV integration in smart grid by a small video. I'll not play the full video, just I will start the video and explain, and then we'll go to the next slide. So you can see that they're telling that EVs and smart grid are going to get married. Okay, so that term is being used. What are the challenges ahead while integrating EVs with smart grid? So what will happen is there will be a switching surge which is created. If all vehicles are electric vehicles, all vehicles are charging at a time, then there will be a load which is exerted on the grid. So that will create a switching surge. First one is the switching surge problem. Second one is your load management. So EV is also going to power your grid in the form of vehicle to grid technology. So how we are going to handle this bidirectional flow? Okay. So, so you have just understood what are the challenges that is faced when EV is integrated in smart grid. How we are going to handle the charging infrastructure, how we are going to handle the bidirectional flow, how we are going to handle the load management, and at a time if all the EVs are being charged, how the grid is going to support, what is the point of grid stability. So like that, lot of challenges are there, and hence researchers can work on it. So the major challenges we can put into three major challenges. One is your grid capacity. Okay. EVs, especially as the adoption increases, place additional demand on the grid, requiring upgrades to infrastructure to avoid overloading. So how the grid is going to support for this EV charging. Second is your cyber security, because we are not only having the power flow, we are also having the data flow. So the communication and data transfer, how we are going to secure the communication and data transfer. So the cyber security plays a vital role. And what are the standardization, interoperability? So what are the standards, IEC standards, which we need to follow? Okay, so because here, if you see, interoperability means a smart grid is a network which every system supports another system. So there is a data transfer happening in many directions. How the interoperability issues are going to be handled, and how the standardization between different EV models. Okay, hybrid model is there. In hybrid model itself, different types of models are coming up. So how they are going to handle all these EV models, charging stations, smart grid systems. Okay. So you have two technologies. One is called the vehicle to grid. Another one is the grid to vehicle. So EVs can be more than just consumers. EVs are not just consumers. Okay, they can also be producers of electricity. Okay, so with the vehicle to grid technologies, you can just release the stored energy to the grid during the peak demand. Okay, as a result, you can generate the energy, or not only during the peak demand when the renewable energy generation is low. Suppose if your vehicle is not used for many days, you can, the stored energy can be given back to the grid. Okay, so this will help in balancing the supply and demand. So this is what is called the vehicle to grid technology. From vehicle, you can move to the grid. The power can move to the grid. Okay, so this is the Nissan Leaf EV model, which explains the vehicle to grid technology. So Nissan Leaf model, they are now concentrating on vehicle to grid technology. Okay. Then we also have grid to vehicle technology. That is what normally is happening. You are going to charge your EVs with the help of the grid. Okay. So we are going to do it in the real time by considering factors like what is the grid load, energy availability, and time of use tariffs. So what is the peak time and off peak time? Okay. Now, what is smart charging of EVs? So if you really take smart charging of EV, we need to control the time and rate at which the EV, that is electric vehicle or your car, is being charged. So what time you are going to charge and what is the charging rate? According, so that can be made automated. That can be automated. Okay. So from the grid operator, we can do that. So that is the facility incorporated in the smart charging. And for this, you need a association which is called the DSO association. Like a distributed system operator association, which will have a Pakka communication system and control system, which will be able to manage the charging more efficiently, the time of charging as well as the charging rate. Okay, so this will be able to handle the charging according to the suppose the grid load is high. So whatever the constraints in the grid, based on that, the charging time and rate can be controlled. Okay, So another significant element that contributes to this smart charging is we have to integrate the distributed energy resources along with the grid. Okay, so or the charging infrastructure itself can be powered by the DER sources, that is your solar, wind, and other such sources. So this is the schematic diagram of charging station of EV to grid system. So here you can see the solar photovoltaic we have, then you have the transmission system. So this is the vehicle to grid charging station. Either it can flow in this direction or in the reverse direction, depending upon whether it is charging or it is releasing the stored energy. So here we will have a control center which will monitor everything. What is the data flow, what is the power flow. So everything will be, so here you can see the data flow is shown by blue lines, which is with respect to the ISO control center, which will give the control commands, when to charge or when not to charge, what is the availability of solar power. So that also will go as a data. Then what is the energy price from the power grid control center, then the charging parameters. So this orange color, it shows the power flow. Similarly, here you have seen electric vehicle to grid system. This is electric vehicle to grid as well as to the home system. So this is the schematic diagram. So here you have the vehicle to grid unit with the power flow and the data signals, which is shown. The dotted line shows the data signals. Okay, so you have the from the electric grid we are powering the homes. Okay, the reverse is also happening. Suppose if the home is having the renewable energy system, it is going to power your electric grid. Okay. So, so here you have the electric vehicle which is having a high voltage battery and a control unit. So through the vehicle to grid technology, you can transfer the power or the excess power which is available in the electric vehicle back to the grid. So the key benefits of having this smart charging is load balancing. You can have an efficient load balancing. So it will be able to adjust the charging power based on the load conditions of the grid. What are the times at which the charging should happen? So during the off-peak times, it will allow for charging. So this in turn will prevent the congestion which is happening in the grid. So this is one of the automation, that is the efficient load balancing. Then pricing, what is the charging price? So generally we can go for dynamic pricing. Even for the electricity, we can go for dynamic pricing if you go for smart meters. So if you use your appliance at peak time, your charge will be high. If you use the same appliance at off-peak times, your charge, your electricity charge, your cost will be less. Okay, so we can go for a dynamic pricing model. So that also will be favorable to the customers as well as to the utilities. And location-based charging. So you know that in cities, in certain places, it will be a highly densely populated place. So how we are going to manage in that places, in the areas where the grid is already stressed, charging stations can be distributed. You can have more number of charging stations so that the load will be distributed. Okay. So this is the nutshell I just wanted to give. So although, see, the time is very limited, I could not go into deep into any particular technology, but I have just given an overview. Depending upon your interest, you can further go deep dive into the topic, maybe vehicle to grid technology or smart grid also. If you're really interested, there are a lot of scope in the distribution system as well as in the transmission system, converting the substation into automation. Okay, a lot of features you can add, a lot of research topics are there, so you can explore it. Okay, and I'll just I think there are 5 more minutes, right? I'll just wanted to play a quiz with you. Okay. 1 minute. So if you, I think many of them are using a mobile phone. Okay. Can I take another 5 minutes? Is it okay for you? Hello, is my voice audible? Hello, are you there? Are you able to see this game on the screen? It's a quiz game. Now, I want all of
Yes,
you
ma'am. Yes, ma'am.
to just go to Google and type. So first come, first serve basis. So this is actually the freeware version I'm using. So only 20 participants can join. Others can observe. Okay. So you have to go to Google, type this website, and then I will show you the game pin. Just enter the game pin 894821. Participants, are you there? So you have to go to the website www.kahoot.it and enter the game pin and give your name. Hello. So can you quickly log in? If you have any doubts also, you can ask parallelly. So I've just given a brief overview of the concept of electric vehicles, smart grid, and how they are integrated. Hello.
Ma'am, your voice is audible, ma'am.
My voice is not audible.
Ma'am, your voice is audible, ma'am.
Are you able to see the screen?
Yes, ma'am.
Okay.
Your screen is visible, ma'am.
If you have any doubts or anything related to research in which topic you can do, you can ask. Or else if you are doing research on any specific topic and if you have any doubts also, I'll be happy to answer. So you can quickly join. Okay, I'll start the game because we are running out of time. Others can also join in the intermediate. Okay. I don't know how many participants are there. Everybody will be hungry now because of dinner time. Okay. So let me start the game. I have 10 questions. You can also join in the intermediate. The game pin will be available on the screen below 894821. So this is the first question. Please put your answers. You have the color codes on your screen. Which one was the key challenge in the transition from IC engine vehicles to electric vehicles? Nobody is answering. Why? Put your answer now. So what is a major challenge? The major challenge is insufficient infrastructure, not safety. Safety is not a major challenge. Insufficient charging infrastructure. Okay, Satya is leading. Good. Which of the following is true about plug-in hybrid electric vehicles? So the answer is, yeah, good. They have a small internal combustion engine and large battery. It's a correct answer. Which of the following best describes a vehicle to grid system in the context of smart grids? It's a very easy question. The answer is the first option. Satya is leading. Good. What is the main goal of smart charging for electric vehicles? So to ensure charging occurs at off-peak times to reduce the grid stress. That is the main goal of charging stations, smart charging. Satya madam is leading. Good. Next we have a true or false question. So answer is true. What is the best way to integrate solar energy into the EV charging process? So the best way is you have to use smart chargers so that based on the solar energy availability, the charging will happen. Nivi is now topping. Okay. Which of the following strategies would you implement to support electric vehicle adoption in urban areas? So you have to implement DER. Most of them have given the correct answer as well as smart charging. Good. Again, Nivi ma'am, Nivi is stopping. I don't know from which college. What is the primary purpose of regenerative braking in an electric vehicle? Very easy question. So most of them have answered correctly. Which technology enables two-way communication between consumer and utility companies in a smart grid? So it is AMI. AMI is the one which allows, not electric vehicle charge, because this is charging station. Okay. So AMI is a technology which allows for two-way communication. So we'll be knowing the energy consumption, we'll be accordingly controlling the appliances. The last question. Which of the following is a benefit of V2G technology? Okay, the correct answer is allows EV owners to earn money, providing power back to the grid during peak demand. So the third position is backed by JB. I don't know who it is. Second by Satya and first by Nivi. Congratulations to the winners. Runners are Uma and Kavi Sundar, I think. Okay. So appreciations to the winners. So if you have any doubts, you can ask now. Hope you enjoyed this small quiz game. If you have any doubts, you can ask now. Almost all of them
Participants,
have left. Was the session useful?
Highly useful, madam.
useful, ma'am.
Thank you, sir. If you have any specific questions, I am ready to answer for that. Sorry for the interruption. Some interruption happened in the middle. Sorry for that. Okay. Some questions are. What are the main challenges in integration with the grid and what are the solutions? Yeah, the main challenge is grid stability. See, and the solutions, if you see, the grid need to be more robust and it should have the sufficient power capacity. For example, the DERs. Okay, so the sufficient capacity should be available so that it will be able to pool the necessary power. Okay, so the real scenario will happen only when the case arises, when all the vehicles are converting into the smart grid. Okay, so here all the vehicles are converted into EVs. So here, if you see in Western countries and in other foreign countries, already the grid network has been made into a smart grid network. Okay, by adding a lot of DR resources and all. But in India, still it is under promotion. So the major challenge is grid stability, and the second challenge is how we are going to handle the data which is going to be populated in the cloud environment, how we are going to secure the data. Okay. So that is also a major challenge, and how we are going to integrate more number of renewable energy sources into the grid. Okay, making the charging station as a smart charging station. These are the main challenges. I hope I've answered a question. Manu Kumar Singh. Capacitor bank with EV, no sir. Actually, capacitor bank will be used only for reactive power management. Okay, so when you go for EV, we are using batteries which is purely only consuming the real power. So we are not worried about the reactive power. I think, of course, but in the grid, when you convert the AC to DC, you have to handle the thing. But the grid, towards the grid side, we need to have a stable. Okay, the power factor should be maintained at a higher level. So that will be towards the grid side, but not towards the EV side. So I think he is very good. He's asking good questions. So there are a lot of scope of research for these topics. So in 4 or 5 years before, we are all thinking, oh, what has happened to electrical engineering? It has gone down, nothing like that. Okay, now electrical engineering is going to come up in a high pace. So there is a high want of electrical engineers in various industries, especially in the field of renewable energy, automations in grids, as well as in EV industries. So you can tell your students, if they are proficient in any one area, even if they are proficient in applications of AI/ML techniques to battery management system, they can get jobs in good companies. So ask them to do projects efficiently, and as teachers, you can also guide them. Any other doubts you have?
Kalyani ma'am, thank you ma'am. Kalyani ma'am, thank you very much. Midun, are you in?
Yes, sir.
Ma'am, Aishwari, you can formally conclude.
Thank you, ma'am, for making this session as interactive and informative one. You have shared the insights of electrical vehicle and how it benefits by compared to traditional vehicle. You have explained elaborately about the components of electrical vehicle and compared electrical vehicle of the various companies in terms of operation, features, and cost. This knowledge empowers the faculties to guide students in tackling real-world challenges and advancing sustainable practices. Once again, thank you, ma'am.
Thank you, sir. Thank you. Yeah.
Thank you, Kalyani ma'am. Thank you, ma'am.
Yeah. Thanks to all the participants and especially HOD sir, Dr. Prince, for inviting me. Sorry for consuming your lunch, dinner time. Okay. Thank you. Wish you all the best, everybody.
Thank you, ma'am.
Wishing the program a great success.
Thank you, ma'am.
Thank you.